Now let's continue with the previous calculation. So now let's calculate for the beam A2, A3. Let me highlight it over here for you to see. A2, A3 is this beam over here. And you see that the beam over here, a half of this slab, we transfer the load to that beam. So the length of the beam will be 30 and the width of that is the same thing, 12.5. So the formula over here will be just the same, U multiplied by 3 tributary width will equal to the same thing. U will be 240 and tributary width will be 12.5, the same thing. So this one, the result will be the same, 3000 PLF. Similar like that, you can apply for B2, B1, B2, B1, B2. And because B1, B2 is over here, and the low in this one will be a half of this slab and will be a half of this slab over here. We load to B1, B2. So the length will be 20 and the width will be this one a half of 25 divided by 2 is 12.5. 12.5 plus 15 divided by 2 is 7.5. So this one will equal to 20. We equal to 20. So this one will equal to basically to 240 multiplied by 20. This one will equal for, oh this one, sorry, 3000 PLF. Let me write this one clearly, otherwise you might confuse. 3000 PLF. Similar like that, B2, B3. If you calculate for B2, B3, this beam over here, right? So a half of this one, and a half of this one, and the tributary width is just the same, 20. So this one we have the same value, that will be 4800 PLF, right? Similar like that, C1, C2, C1, C2 is over here, and the tributary width of that will be a half of this one will be 7.5. So we have 240 multiplied by 7.5. I will have 240 multiplied 7.5. I will have that one is 1800 PLF. Similar like that, C2, C3, we have the same value, 1800 PLF. And then we have A1, B1. A1, B1 over here. So A1, B1 will be this, and a half of this slab will have load to A1, B1. tributary width of this one will be 20 divided by 2 will be 10 feet. Okay, so this one I will have 240 multiplied by 10. I will have this one is 2400 PLF. Similar like that, B1, C1, we have the same tributary area. This one will be 10, so this one we have 2400 PLF. Okay, next one is A2 B2. A2 B2, we have the tributary area is this. So the width of the tributary area is this one, a half of this one is 10, a half this one is 15, will be 25 feet. So this one will equal to 2400 multiplied by 25 will be 6000 PLF. Similar like that, B2C2 we also equal to 6000 PLF. A3B3 A3B3 is over here. A3B3 is over here. A half of this slab over here we load to that beam, and a half of this one is 15 feet. So we're gonna have this one is 24 0 multiplied by 15 equal to 3600 PLF, and this one also similar like that will be 36 PLF. Now let's calculate for the column, the load on the 4th floor column. The building over here have 4 floors. 1, 2, 3, 4. Okay, 4 floor. The 4th floor is this column. So this column will receive only the load of the slab over here, the top slab. Transfer the load to this column. So then, first of all, we can just see how many columns do we have over here. Let's pause the video and count for me how many columns do we have in this figure. So if you count, you're gonna see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Okay? So we're gonna call them based on the grid line. So this one will be A1, this one will be A2, similar like that, so on and so forth. So I'm gonna have this one is E. I'm gonna have column A1, A2, A3, B1, B2, B3, C1, C2, C3. Now let's check column A1 first. Now let's check the formula sheet. You have that for column the value, the load on the column will equal to U multiplied by tributary area and of the floor above it, of the floor above it. So I can apply it over here. This one not correct. So equal to U multiplied by tributary area multiplied by floor above it. Alright, so first of all, U, we already know from the previous calculation, this one is 240, similar to the other one, that is the combined load. Now the tributary area, let me draw this one more time. So you see this one is column A1, right? Tributary area of that will be this piece, 1/4 of the slab over here will load to this column. The other pack over here will load to this column, and for this column over here, this is the load of that, so on and so forth. So the tributary area over here, we have the area is 12.5 multiplied by a half of this one is 10. So you see that this is a rectangular, and the rectangular over here we have the area is 12.5 multiplied by 10. So if I put this one over here is 12.5 multiplied by 10, and a floor above it, like I mentioned previously, this one on the column on the top floor over here, so only one floor above it, so I can replace over here is just 1. So the value over here will equal to 240 multiplied by 12.5 multiplied by 10 multiplied by 1. I will have this one is 30,000. And what is the unit over here? This one is feet. This one is pound over feet square. So if I eliminate 1 feet over here, 1 feet over here with number 2 over here, so at the end what I have left is pound only. Next one is A2. A2 similar like that, we just let U multiply by tributary area multiplied by the floor above it. The U will be just the same, 240 tributary area of A2. A2 will be this one. Because A2 not only received the slab over here, but it also received the slab over here as well. So the tributary area of A2 will equal to this piece is 10 plus 15 is 25, and from here to here that one is 12.5. So I'm gonna have this one is multiplied by 25 multiplied by 12.5 multiplied by floor above it is 1. And over here we have 240 multiplied by 25 multiplied by 12.5. I will have this one is 75,000 pound. Right? Similar like that for A3. You can check A3 over here. So A3, this is the tributary area. From here to here, the thickness of that is 15, 12.5. So I'll let 24, 0 multiplied by 15. That 15 multiplied by 12.5 multiplied by 1 equal to 45,000 pounds.